So I made a few changes already, but let's see if we can work this out. We have to know how to write these K reactions, right? What was one of these K reactions, Victor, that I'm talking about? K what? K? Yeah, with a little subscript. K, A. And that's another one. A KB. We've got one more, Jasmine? KSP. Okay, now when you write the reaction for each one of these, there's a real hint. I don't know if you've noticed it so far. That subscript is always a reactant. A, the conjugate acid, it's a reactant. KB, the conjugate base is a reactant. KSP, the solid's the reactant. Okay, so Roland, if I want to write the general Ka reaction, how would that go? HA. Yeah. And then James, the KB reaction, that would go, has to be the base. The conjugate base we said was A minus. This is going to kill you if you don't know these. Anybody help them? Conjugate base plus H2O yields OH and HA. Man, if you guys don't know these, you can't even row the boat. You can't, you can't even play the game. So you got to know these. KSP, we don't have a reaction for it, just in general. What would you write on the reactant side? Always the solid. So I'm just going to write solid, little s. And it always goes to its what? Break up the solid into its aqueous. What makes up the solid? There's an I. Ions. And we hardly ever write aqueous, but it's good practice too. So know how to write those. And then the Ka or Kb or KSP expression, that's always just products over reactants, right? Okay, I added this since your handout, I actually added it this morning, just to remind you, right, that you're given a KSP table, a KB table, a Ka table, right? And then there are some equations and constants. Now let's see if you remember what. Now I give them to you. Let's see if you remember these equations that I'll be giving you. Vanessa, you remember one of the equations that you're going to be needing? Oh, you're talking about that quadratic formula. Okay, that's where you have ax squared plus bx plus c equals 0. I don't remember if we had that or not, honestly. I know we had it in the last exam. How about another relationship? How about pH? That's equal to negative log of H plus. What else? Do you remember? There's, besides pH, there's POH. Okay, there's a few more. Ooh, that's a good one. pH plus POH is 14. Right? I can think of two more. Yeah, KW is what? I guess there's three more, because that's a good one. KW is equal to what times what? There it is, Kb times Ka. Okay, now there's one more. The B word. Buffer. I don't know if you, Henderson-Hasselbalch equation. We use this a lot. pH equals pKa plus the log of the concentration of the well, this is how we wrote it. But in use, in practicality, we didn't really use this. What we used is the log of, this is really the conjugate base over the conjugate acid, and we didn't use concentration. We just said what? Moles. Because the liters ends up canceling. It's a little bit easier. So moles of conjugate base over moles of conjugate acid is what we really used for buffer problems. Okay, so all that stuff will be given to you. Okay, so all of this stuff is your homework, right? If we start here, but before we just jump into this, I want to make sure you catch this trick question. It's not really a trick question, but it looks like one. Let me ask you, do you have to use ice to solve this question? That's the key. Is this a strong acid?
No, it's not.
It's not, right? HCl, HBr, and HIR. So pH is pH is a negative log of hydrogen ion concentration. But you can't say that it's 0.29 molar. It's a lot less because it's a weak acid. So do you have to do ice to solve this? Yes, most definitely. So what I'm saying is read these careful. Don't just jump into ice. What if this, instead of being HF, was, pick one. And there's 6 of them. HI. What if this was HI? Then the pH would be the negative log of 0.29, right? If it was a strong base, KOH. Well, then you can't calculate pH. You can calculate POH and then figure out what it is, subtract it from 14, and you'd have pH. Okay, but so I just wanted you to realize that stuff. Okay, so the question is 0.29 molar HF. So, well, we can work this first one together, and then we'll let you have at it here. What reaction do I need to write? A K what? It all depends on what's there initially. Has to be a Ka reaction because it's a acid. So HF, H plus, and F minus, right? And then we just do ice. We've done this a gazillion times. All right? So we need to look up the Ka for HF, right? And that Ka is 6.8 times 10 to the negative 4. That would be approximately x squared all over, everybody? .29, right? And I can do that because it's 10 to the negative 4. That's just at the limit. Anything's a bigger number than that, we're screwed, but we'll live with it. Okay, then we solve for our x. And go back to the ice table to see what x actually is. Because sometimes x is hydroxide, not hydrogen ion. So you go back to the table, oh, x is hydrogen ion concentration. So we'll end up taking the negative log of our x, and we'll have our answer. So go ahead and work on these. Work on them together. Any part, any component you get stuck, just ask. And since this is homework, we're not going to go to the boards because you got to turn all this stuff in. So I got about 1.85 for this first one. Okay. Diatomic. So you're not going to see those. HCl, HBr, HI, HNO3, HClO4. 1, 2, 3, 4, 5. Now there's only one more. And this one is diatomic. Sorry, diprotic. H2SO4. So very often you don't see problems with H2SO4 because it's complicated. You have a strong acid, and then you have a weak acid, HSO4. So you'd hardly ever see that at all in general chemistry. It's going to be those above it. So HNO2. Let me look up some of these Kas for you so you don't have to dig them up. 4.5 times 10 negative 4. So in 2, will that be definitely not one of the 6. It's going to be ice, but ice of what type of reaction? Has to be Ka again. Some folks get confused, though, because they think, oh, it's asking for POH, so I have to write a Kb reaction. No, it's an acid. You have no choice. You have to write a Ka reaction, even though they want POH in the end. Yep. $11.5. It sounds like a familiar number, but it should be a POH. It sounds right. It's POH, so pH is going to be acidic, so it sounds like. No one's got an answer yet. Yeah, 11.5 for POH. Remember, your X is hydrogen ion, so when you take the log of it, you got to subtract from 14. Because X is hydrogen ion in the ice table. I don't know if you guys have the table, so let me keep looking these up. Here it is. 1.7 times 10 to the negative 6. So for number 3, I looked up found hydrazine N2H4 in the table. Found it in the KB table, so I wrote down it's KB. They want to know what is the pH of 0.9 molar hydrazine. Yeah, you have to write a KB reaction because that compound is a base. And the only way you know that is by finding this in the KB table. So you have to write a KB reaction for this. So this would correspond to the A minus. Yeah, this would correspond to the A minus. Because our general way of writing conjugate base was A minus. So actually you could get away with that, James. You could do this, and you can get the right answers. You'll get the right answers, but it doesn't look as nice. It looks better writing it as it looks better that way. But mathematically, you get the exact same answers. Oh, I did. I added it in both places. Thank you, sir. It's added in one place or the other, not both. Yeah, you have to do ice for everything that's not a strong acid or strong base. You have no choice. They're all equilibrium problems. 11.09 about. Yeah. I got it same as Roland, somewhere around 11.09, 11.1, something like that for number 3. Yeah, good. See how this one's easier if you leave the Na out, though. Yeah. Pretty much it's always just disregard those alkali metals. Yeah. And it looks so much better. But this is right. This will work because you wrote a Kb reaction, so it will work. You need the Ka for HCN. HCN, 4.9 times 10 to the negative 10. If you're working on 4, Victor, are you working on 4? Yeah. Okay. What was, yeah, what, disregard that for now. What, do you recognize, is this an acid or a base? It's not so obvious. But don't look at what, Jasmine? Don't look at the Na. Now you look at it. Is that an acid or a base? It's a conjugate base. So you have to write a Kb reaction. So this has to be a Kb reaction. And just leave the sodium out. It's so much cleaner. Right? You can leave it in, but it's just kind of cleaner if you leave it out. You have to write a Kb reaction for cyanide. That means you need a Kb for cyanide, but it is not in the table. So that's why you have to look up the Ka for HCN and calculate the Kb. So these are so much easier if you don't look at those alkali metals. It's easier to recognize what it really is. It's a conjugate base. Sodium's there just so you can put it in a bottle. Make it a neutral compound. Yeah, Cn minus corresponds to your A minus. Exactly. Oh, but you got to calculate your Kb. You got to calculate your Kb. Jasmine, did you get like 11.63 or something? Perfect. Now that number 5 is that Henderson-Hasselbalch equation that we wrote down. You remember how to get moles? Pretty much you just multiply volume. This has to be in liters though. Remember doing this? So pKa is just negative log. So the little p just means take negative log. So pKa must mean take negative log of Ka. Yeah. See, which one is the base? Is it the first one or the second one? Second one. And remember, big M is moles over liters. So pretty much just multiply these two to get moles. But make sure this is in liters. So multiply this one times that one. As long as you're in liters, it'll work. Your part B, I kind of added this one. Your part B is actually this part C, but I wanted to do this one first. Do you remember when you add a strong acid, what has to react? in order to, so the pH doesn't change so much. The conjugate, and in that buffer, you've got a conjugate acid and a conjugate base. If you add a strong acid, the conjugate, what can react with an acid? Only a base. So the conjugate base has to react. So figure out the moles of the strong acid, subtract that from the moles of the conjugate base, add it to the moles of the conjugate acid, because that's what it gets converted into. So use the exact same equation. Just copy it all down again. Everything's the exact same equation. See, all I did is I just copied it. Except I have to realize this is the moles of conjugate base, so it's going to decrease a little bit, and this number is going to increase a little bit. So a minus and a plus, what number? This. Multiply those two. Make sure this is in liters, though. So this would be minus and plus. If I would have added strong base, this would have been plus and minus, top and bottom. pH should go down a little bit. It shouldn't go down too much at the buffer. It'll probably go down to like 7.33 or 7.32 or something. You know you're doing it right. So we're pretty much out of time here. Let's see if you can knock out the rest of these questions. And feel free to ask me tomorrow at our symposium.